Hello, my name is Malinda Gamage and this is my MSc project demonstration. This system is context-aware next best action platform for pharmaceutical field operations. The problem I am addressing is that medical representatives often decide who to visit next using static schedules, personal judgment, or fragmented information. My system improves that process by combining operational contexts such as doctor priority, visit recency, follow-up needs, pharmacy feedback, schedule constraints, and sales signals into explainable rank next actions. The software is implemented as a React Progressive Web App Frontend, a Spring Boot Backend API, a Python recommendation service, PostgreSQL with PostGIS for data and geospatial support, and KeyCloak for secure authentication and role-based access control. Now I will start the main services required for the next best action platform using Docker. I will run the Docker Compose setup, which starts PostgreSQL, KeyCloak, the NBA API service, and the recommender service. PostgreSQL is used as the main database for the storing application data. KeyCloak is used for authentication and role-based access control. The NBA API provides backend REST endpoints, while the recommender service generates next best action recommendations. Once the containers are running, I will open KeyCloak and confirm that the real client users and roles are configured. Then I will open the React application and log in using a valid KeyCloak user account. After successful login, KeyCloak redirects me back to the React app, where the dashboard is displayed according to the user's role. This confirms that the local Docker environment is running correctly, authentication is working, and the frontend can connect with the backend service. I will now demonstrate the system role by role, starting with the medical representative workflow, which is the core of the platform. I am now logging in as a medical representative. Authentication is handled through KeyCloak, and after logging, the system routes the user based on their role. This is important because different users see different capabilities. For example, the medical reps sees the operational recommendation workflow, while managers and administrators see analytics and governance functions. This is the medical rep dashboard, which is the main decision support screen. At the top, I can see summary indicators such as current workload and activity context. Below that, I can see the rank next best action generated by the system. Each recommendation is not just a score. It includes the doctor, the recommended action, explanation text, and the factor level drivers behind the ranking. That is a key contribution of the project, because the system is designed to be explainable and actionable, not just predictive. I will focus on the top recommendation. Here the system shows the doctor name, the recommendation score, the recommended action, and the explanation. It also shows the main drivers, for example recency, time of day, fit, product focus, pharmacy signal, or follow-up need. This directly addresses one of my core research questions: how to combine multiple contextual signals into useful next action while still making the reasoning transparent to the user. What matters here is that the recommendation is operational. That system does not simply say this doctor has a high score. It tells the representative what to do next, such as revisit the doctor, follow up on previous action, or visit a pharmacy first. This makes the output usable in daily work rather than just informative. The explanation layer also helps build trust, because the user can see why this recommendation is being prioritized. The dashboard also supports schedule-aware planning. Here the medical rep can define workday start and end time, break periods, maximum visits per day, base location, and planning notes. These settings are important because recommendations should reflect not only doctor importance but also the representative's actual working constraints. So, this part of the system helps ensure that recommendations are realistic and not detached from the operational day plan. The dashboard also supports route-aware execution. I can view destination context, nearby doctors and pharmacies, and navigate towards the most relevant target. This is useful because decision support is not complete unless the user can act on it in the field. In other words, the system does not stop at ranking, it also supports execution. One of the distinctive features of this project is the pharmacy feedback loop. Here the medical rep can capture field intelligence from a pharmacy by selecting the pharmacy, selecting the assigned product, optionally linking a doctor, and recording whether the product is being prescribed and whether stock is available. The user can also add notes. This is important because the platform does not rely only on doctor history, it also uses downstream pharmacy evidence to influence future recommendations. I will now submit a pharmacy feedback record. I can also submit feedback on a recommendation itself. For example, I can mark this recommendation as done, skipped, or rescheduled, and I can record a reason or reschedule date. This closes the loop between system generated advice and actual use action. That is essential because the platform is designed not only to suggest actions but also to learn from what users actually do and make that visible in later analytics. The system is also designed for real field conditions, including unreliable connectivity. If the representative is offline, selected actions such as feedback and visit related activity can be queued locally in the browser. When connectivity returns, the user can synchronize the queued actions and any conflicts are clearly reported. This offline first capability is one of the strongest practical aspects of the project because field software must remain usable outside ideal network conditions. I will now open the doctor directory. This screen allows the user to search and segment doctors by specialty, tier, priority, and location mode. This user can view availability, target product focus, location details, and communication channels such as WhatsApp and email. For managers and administrators, this screen also supports doctor creation and editing, including availability windows, scheduling notes, and geolocation. This screen supports the wider data quality and operational context needed by recommendation layer. This is the visit log, which records recent physician interactions and outcomes. Visits can be filtered by status such as completed, skip, or rescheduled. Visit data is one of the most important input into future recommendation generation because recency, follow-up needs, and visit outcomes all affect how the next best action is calculated. I will now switch to the sales representative role to show how commercial side of the platform contributes to the overall decision support model. This is the sales rep dashboard. Here the user can see assigned products, the target territory, available pharmacies, and a draft order summary. The sales representative can capture a pharmacy order in real time by selecting a pharmacy, adding one or more product lines, entering quantity and amount, and then submitting the order. I am now submitting a pharmacy order. This functionality is important because pharmacy order and sales data are not isolated. They contribute to the wider commercial context used by the manager dashboard and they are relevant by the recommendation logic. I will now move to the manager role because the project is not only about frontline recommendations, it also provides supervisory visibility. This is the manager dashboard. Here the manager can review operational performance using key metrics such as total visits, NBA acceptance rate, average coverage, and day plan configuration coverage. Below that, the system provides territory coverage, compliance breakdown, weekly visit trends, missed high priority doctors, coaching indicators, and sales target performance. This demonstrates that the system supports not only action delivery to field users, but also monitoring, coaching, and evaluation at managerial level. The manager can also define weekly sales targets for specific sales representatives and products. The platform then compares targets against actual execution. This helps connect strategic expectations with real field and pharmacy activity, which is important for operational control. The dashboard also includes pharmacy sales trends, which show order behavior over time. This is useful because it adds commercial evidence into managerial decision making. In addition, the manager can search and assign pharmacies using Google Maps, which helps extend territory coverage and improve field relevance. This territory view shows how territories are structured, how many doctors they contain, how many representatives are assigned, and what the coverage level looks like. This provides a higher level operational view of the field structure. Finally, I will show the administrator role, which focuses on governance, scoring control, and auditability. This is the admin setting area. In the scoring rules section, the administrator can review and update the recommendation weight configuration. This is important because the recommendation model is configurable and version rather than fixed invisibly in one place. The products section provides visibility into the active product portfolio and doctor assignment counts. The security section represents governance related controls, and the audit log provides traceability of action taking place in the system. This supports accountability and administrative oversight. To conclude, this project demonstrates a complete context-aware software platform for pharmaceutical field operations. It supports secure multi-role access, explainable next best action recommendations, visit and feedback capture, pharmacy and sales integration, offline first operation, managerial analytics, and administrative governance. The key contribution is that the system does not simply digitize records. It transforms operational, behavioral, and commercial data into explainable and actionable decision support. Thank you.